Okay there, class. We had just left off with understanding a little bit about how numbering systems work. Specifically, we were looking at something called a cipher and how a cipher is used to represent digits in a number. Let me scroll down here. Just recall some things we had learned. We had learned about 4 different systems, and again, there's many more than this that we could use. These are some commonly used ones. But a decimal system, which is the one we're familiar with, uses the ciphers 0 through 9. A binary system uses the ciphers 0 through 1. Octal system uses the ciphers 0 through 7. And the hexadecimal system uses the ciphers 0 through F. So let's take a look at how we count in a numbering system. Let me get it over here on the screen and zoom out a little bit. There we go. All right, so in our familiar base 10 system, of course, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're very familiar with how that works. Now I want you to think about this carefully here. As we get to the number 9, notice we've run out of ciphers. Okay, and when we run out of ciphers, what we actually do is think about this place value. This place value here is known as the ones place value. We reset that to the original cipher, the 0, but then we increment the next place value over, which we know here is the tens place value. We increment that to the next place value, to the next cipher. So notice how this one uses the cipher 1, the number 11 uses the cipher 1, the number 12 uses the cipher 1, 13, 14, 15, 16, 17, 18, and do I have 19 on my list here? Is it on here? Let's see. 19. Okay. And of course, once we get to 19, we've run out of ciphers yet again. And we would increment the tens place value to the number 20. And this would reset itself to a 0. Now let's use that same line of logic when we talk about different base systems. So in the binary system, just like in the decimal system, we're going to start with our first cipher. We are allowed to use the cipher 1, or I'm sorry, we're allowed to use the cipher 0. We can then use the cipher 1 to count. Now here's the issue. We've just used all the ciphers that we have available. We only have the ciphers 0 and 1 available. So what we have to do is we have to reset this place value, but then we have to add a place value right here. And that place value we add is a different place value. We'll learn that this is the 2's place value, where down here our place values, this is the 1's place value and the 10's place value. This is actually the 1's place value and the 2's place value. Now let's continue to kind of count up in the base 2 system, where we have 0, 1, 1, 0. We can then increment this to the next cipher right here. And once again, we've run out of ciphers. The only ciphers we have to use are 0 and 1. So we have to go to the place value next door. So the place value next door, we're going to increment it by 1, go 0 and 0. Then our next place value, sorry, not place value, but the next one would be 0, 1, 0, 1. We've run out of ciphers here. So it's going to be 1, 1, 0. Then it's going to be 1, 1, 1. And again, notice how we've run out of ciphers to use. We've incremented everything to the maximum. And so we have to go to the next place value over, which just happens to be the 8's place value. So it's going to be 1, 0. We reset all of the other ciphers. Then it's 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Notice how we've run out of ciphers here, so we have to go back here and increment 1, 0, 0, 1, 1, 0, 1. Okay, I'd like you to finish the rest on your own, and when you pick up with me again, you'll see that I have filled out this chart. Okay, so if you took the time to actually think this through, this is actually what you should end up with here. Notice once we get to the number 15 in the decimal system, we've used up all the ciphers. So hopefully you understand at this point, we actually have to go to the next place value over. And this is actually in the in the binary system is known as the 16's place value. And so we have to increment, and just like here, when we get to the next place value, or when we use up all of our ciphers, we would have to increment. So of course, in our decimal system, we would go to a 20, 21, dot, 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 and eventually we get to 29. We've run out of ciphers. You're going to go to the 0 and increment this by 1. Whenever we get all the way to 99, we've used up all the ciphers in these place values. So we reset both of these, and we have to go to the next place value over, which of course we know in the decimal system as the hundreds place value. All right, in our octal system, we have 8 different ciphers that we can use. We can use the cipher 0, 1, 2, 3, 4, 5, 6, and 7. We've run out of ciphers at the end of 7. So what we have to do, as in all systems, we have to reset this to 0, and we go to the next place value over. This happens to be the 8's place value in the octal system. And likewise, we're going to keep that the same. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Let me scroll down. 1, 7. And notice again, we've run out of ciphers. We cannot use an 8 in the octal system, as kind of counterintuitive as that might seem. Because again, you have to remember, we've used a 0. That's our first cipher. So there's 1, 2, 3, 4, 5, 6, 7, 8 ciphers used. So we're going to reset our cipher. You have to increment this by 1, and there is the equivalent to 16 in the octal system. Let's go over to a hexadecimal system. Now remember, in the hexadecimal system, we are allowed 16 ciphers. Our first one is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, under most systems, at this point in time, we have run out of ciphers. But in the hexadecimal system, we are actually not out of ciphers yet. We have the cipher A. So the letter A, or the cipher A in this case, represents the number 10 in the hexadecimal system. B is the number 11, C 12. What comes after C? Oh, D, E, and F. And so that would give us all of our 16 ciphers. Now I'd like you to stop the video for just a moment, and I'd like you to make a prediction. What's the next number in the hexadecimal system? All right, welcome back. So in all of our systems, as we run out of ciphers, we reset this to the original cipher, and we have to go to the next place value over. In this place, in the hexadecimal system, this is the 16's place value. So we have to put a 1 here. That's a 1. Then we go to 1, 1. And let me see if I can scroll down here. Oh, I don't know what's happened there. One, 2, 1, 3, so forth and so on. Let me scroll down here even further. Okay, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1A, because remember, we haven't run out of ciphers yet. 1B, 1C, 1D, 1E, 1F. And at this point, we have run out of the ciphers in our 1's place value. So we have to reset to the 0, and then we have to increment the 16's place value to the digit 2, or the cipher 2. And then, of course, this procedure would repeat itself over and over again. All right, one little note of clarification here. Let's take a look across. Let's go down here a little bit further on my list. For example, let's take a look at, let's say the number 17 here. Okay, now it would be really easy to confuse here that when you look at the number 17 and you look at the number, what appears to be an 11 over here, that these two are in fact the same exact number. They are, of course, are in two different systems. This one being in the decimal system, and this one being in the hexadecimal system. So sometimes what we'll do here to just clarify, to make sure that we understand what system we're dealing in, is that since this is a base 16 system, we will put the base, why is it not letting me write? There we go. We put the base 16. So let me write it over here. It's a little more clear. We would write 1, 1 with the base 16. Okay, this subscript would indicate that the base number there is 16. So this is not actually the number 11, that it actually is, in fact, the number 17. Likewise, in a base 2 system, if we looked at, let's say, the number 9 in a base 2 system almost appears to be the number 1001. Now, of course, this is not true. This is in the base 2 system, so what we would write is, for clarification's purposes, we could write the little subscript of 2 there to indicate that it is a base 2 system. And so that can be how we reference and make sure that we're very clear on what kind of system we're dealing in.